In this lecture, we want to look at the language of hypothesis testing. Now, this is an incredibly important lecture as the terminology and concepts that I discuss in this lecture are going to come up over the next couple of lectures on hypothesis testing. So this kind of like sets the groundwork for it. So I encourage you to make sure that you pay attention to the entirety of this lecture. Okay, so we're going to get through three objectives in this lecture. We want to talk about and determine what is the null and alternative hypothesis, two very important hypothesis statements. I want to explain what type 1 and type 2 errors are for hypothesis testing. And then I'm finally going to end with talking about how you state conclusions to hypothesis tests. So in this lecture here, it's just the language of hypothesis testing. We're not actually going to do a hypothesis test until a lecture or two after this one. This is just kind of like just setting everything up for you. Okay, so let's talk about how you determine what the null and alternative hypothesis are. Okay, so first off, what is a hypothesis? So a hypothesis in statistics is a statement regarding a characteristic of one or more populations. Okay, so in this section here, we're going to look at hypothesis regarding a single population parameter. Okay, so exactly recall like what is a population parameter? Well, we have a population mean, which we denote as mu. We have a population proportion, which we denote as P. And then we also have a population standard deviation, which we denote as sigma. Okay. So primarily, we're going to focus over the next couple lectures on hypothesis testing or hypothesis regarding a mean or a population proportion of some type. All right, so when I say we're going to make a statement regarding their characteristic, basically what we're saying is we're going to make a statement regarding their value of some type. Okay? And that'll make like a number. That'll make more sense as you see go through this lecture and as we get to the first couple examples in the next lecture. Okay, so let me give you some examples of claims regarding a characteristic of a single population. So in 2008, 62% of adult Americans regularly volunteered their time for charity. So a researcher believes that the percentage is different today. So this right here, this sentence here is the claim. Okay, so in 2008 it was 62%, so that was a while ago. So a researcher just believes that it's different. It's no longer 62%. Maybe it's gone up, maybe it's gone down, but that's the claim that we want to test, and that's what hypothesis testing is going to be about. We're gonna test that claim, see if the researcher is correct. Another one, according to a study published in March 2006, also a really long time ago, the mean length of a phone call on a cellular telephone was 3.25 minutes. Okay, so this was a really long time ago. So a researcher, here's the claim. A researcher believes that the mean length of the phone call, okay, of a call on a cellular telephone has increased. So there's the claim that the person's making, that for whatever reason we spend more time on our phone. Okay, so it's gone up. Okay, or at least how long our phone calls last, the average phone call. And then finally, okay, so using an old manufacturing process, the standard deviation of the amount of wine put in a bottle, so this is the standard deviation, was 0.23 ounces. So with new equipment, so here's the hypothesis, okay? With new equipment, the quality control manager believes the standard deviation has decreased, okay? So if you notice in all of these, like we made a claim, believes the percentage is different, that it's increased, that it's decreased. Okay, what we want to do now in this section here is talk about how we can prove the claims. So in this section, we look to test the claims. Okay, and by what I mean by test is to see if the claims are true or false. Okay, that's what we want to do. Is the researcher correct here? Is the researcher correct here? Is the quality control manager correct here? Okay, so that's what we want to look at. So we can make these claims, right? And they're pretty valid claims for one reason or the other, but we want to test to see if the claim is right or the claim is wrong. Okay, so this is just a caution about hypothesis testing. So we test these types of statements using sample data. Okay. Okay, so sample data or sample evidence. Okay. Because it's usually impossible or impractical to gain access to the entire population. Okay. So if population data was available, there'd be no need for inferential statistics or hypothesis testing. So we only hypothesis test with sample data. And the great thing, not the great thing, but the interesting thing about this is when we use sample data, there's always going to be a chance we make an incorrect conclusion, right? Like we've talked about in one of our very first lectures, is sometimes you collect a sample, your sample data can have sampling errors in it. Um, and so sometimes you're going to make an incorrect conclusion. And we'll talk about incorrect conclusions in hypothesis testing in a few slides. Okay, so now we have a good understanding of what a hypothesis is. So what is hypothesis testing exactly? So it's a procedure. Okay, so you're gonna the procedure we're gonna talk about, and you'll see this in the coming lecture, is something called a critical value approach or procedure here. Or then there'll be another one called the p-value approach. Okay, that's going to be the procedure I'm going to talk about in the coming lectures. Based on sample evidence and a little bit of probability, used to test statements regarding the characteristic of one or more populations. So we're going to use this hypothesis testing with some sample evidence to test the claims that are made here, okay, in these three examples. Okay, so here's going to be the steps to hypothesis testing. Okay, the first thing you're going to do is make a statement regarding the nature of the population. I think the value has gone up. I think the value is different. I think it's decreased, as you saw in those three examples. You're going to collect evidence, sample data to test the statement, okay? And then you're going to analyze the data to assess the plausibility of the statement. So this is where I'm going to show you we're going to spend most of our time, okay? So this step 3 is the critical value or the p-value approach. You know, this being an introductory statistics class, a lot of times I'm going to give you the hypothesis, okay? It'll be buried in the word problem somehow. And then I will also give you the evidence, so you don't have to go and collect that yourself. So as you go further on in your academic career, especially if you go to graduate school, you'll have a chance to do this, okay, on your own, hypothesis testing and collect data. Okay, so hypothesis testing. So hypothesis testing requires two statements. So why does it require two statements? Well, because a claim can either be correct or incorrect. Okay, so because a claim can be correct or incorrect, okay, like if I go back just real quick for a second, like in this one here, any of these, the researcher believes that the percentage is different. Well, maybe they're right or maybe they're wrong. You don't know until you do actually do the procedure, hypothesis testing. Okay, so we need two statements to handle the case that either the researcher is correct or incorrect. Okay, so we need something called a null hypothesis and an alternative hypothesis. So you'll see this in the coming slides. The null hypothesis is denoted with an H with the subscripted 0, and the alternative is denoted with an H with a subscripted 1. Okay. Sometimes I'll always denote it this way, but sometimes you'll see it in textbooks with H with the subscripted A, but I'll always do H sub 1. Okay. So these are two statements when you do hypothesis testing you're always going to have to set up. Okay. So the null hypothesis, as I said, denoted H sub 0, is a statement to be tested. The null hypothesis statement of no change, no effect, or no different, okay, and is assumed to be true until evidence indicates otherwise. So the null, think of it as your base assumption. Okay, another way to think about it is the starting point. Okay, I like to use this example, okay, in the criminal justice system, okay. So the criminal justice system, actually, believe it or not, when someone goes on trial, is a hypothesis test, okay. So you assumed this to be true. So you start with some assumption of truth. So if you think about it, right, when someone's put on trial, the null hypothesis is the defendant is innocent, right? Okay, so like you're presumed innocent until proven guilty. So until evidence indicates otherwise. So it's your base assumption, your starting point. Okay, and you'll see how we set this up with actual numbers and hypothesis testing in a few and statistics, I mean, in a few slides. So then the alternative hypothesis, so I said denoted H sub 1, is a statement that we are trying to find evidence to support. Okay, so H sub 1 is kind of, think about it as what you're looking to show. So if you stick with that example I had, right? So the null hypothesis was the defendant was innocent. What you're looking to show, then the alternative, what the district attorney or the prosecuting attorney is looking to show evidence of, is the defendant is guilty, right? Right? But you always start with this base assumption that the defendant is innocent. So you're assumed true, innocent, and then here what they're looking to show evidence for is that the person is guilty. Okay. All right, so in this section, there's going to be three types of hypothesis tests that we're going to set up. So three types of null and alternative hypothesis tests. We're never going to set them up like this. Defendant was innocent and defendant is guilty. Okay, we're actually going to have to put numbers and notation to it. Okay, so the first type of hypothesis test is what's called an equal versus not equal. And I'll always call it a two-tailed test. Okay, and the null hypothesis will be that the parameter you're investigating is equal to some value. Okay, so remember your parameters are going to be mu, p, or sigma. Okay, and the alternative that we're looking to show is, wait a second, no way, no way, it's different than that. Okay, it's changed over time. So there's going to be keywords that tell you that it's a two-tailed test. Okay, words that are like, I think it's different. I think it's changed. Okay. And please note that this is some value and some value. These are the same numbers. Okay. Same exact values. So then we can have then what's called an equal versus left then. This is a left-tailed test. So here it's your null is that your parameter is equal to some value. Notice that it's the same as up here. Okay. And what we're saying is no way, no way. The parameter is less than that value. Okay. So the keywords here are going to be like, I think the value is decreased. I think it's gone down. Okay, so those type of keywords you see when you do these problems will give away how it's done. And then finally, then we're going to have what's called a right-tailed test, which is equal versus greater than. So again, notice your null hypothesis is always a statement of equality. It's the parameter is equal to some value. And what we're looking to show is no way, the parameter is greater than that value. So the keywords here are going to be values like it's increased. It's gone up. Okay, that's increased or gone up. All right, so whenever a test that happens in this class, it's always going to be one of these three. Okay, and as you come through the lectures that come after this one, I'll do an example of each so you can see exactly like how it's set up. All right, so in other words, okay, so the null hypothesis is a statement of status quo or no difference, and always, as I said, contains a statement of equality. Always, always, always. Okay, so the null hypothesis is assumed to be true until evidence to the contrary. Okay, so we seek evidence that supports the statement and the alternative. Okay, as I've been saying. So null, always a statement of equality. Always, always. Okay, and then the H1. Okay, it's either going to be a not equal to, a greater than, or a less than sign. Okay, always in the alternative. And you're going to use the keywords to figure this out. So use keywords to help with setup. Okay, so let's go those three examples that I had and talk about forming hypotheses. Okay, so for each of the following claims that I had earlier, determine the null and alternative hypothesis and state whether it's a two-tailed, left-tailed, or right-tailed. Okay, so the first one here. In 2008, 62% of American adults regularly volunteer their time for charity. a researcher believes that the percentage is different today. Okay, sorry, I didn't mean to. The keyword here is different. So that tells me that I think that it's different. That this tells me it's going to be a two-tailed test. And the second one, and I'll set up the test in a second, but I'm just trying to show you the keywords. So according to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased. So the keyword there is increased. So this tells me it's going to be a right-tailed test. And then finally, using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control managers believe the standard deviation has decreased. So there's the keyword. So that tells me it's going to be a left-tailed test. Okay, so now now that we at least know it's a two-tailed, right-tailed, left-tailed, let's go and set up the test so you can see how they're done. Okay, so the first one here. Okay, so 62% of Americans volunteer their time. So it's a proportion. So it's going to be the parameter P. So I'm going to set them up a little bit over here so you can see. Okay, so the null hypothesis deals with the population proportion. So it's going to be P is equal to something, and we said it was a two-tailed test, so then it's going to be P is not equal to something. So if the percentage participating in charity work is no different than in 2008, okay, so remember, the null is no difference. So it's going to be, well, it's 0.62, and the researcher believes it's different. So the researcher is now believing, no way, it's no longer equal to 0.62. So this is how we're going to show the hypothesis statements. It's one right on top of each other. We're going to say, all right, P is equal to the original claimed value, all right, and then the alternative is what we're trying to show. No way, it's not equal to that. It's changed. Here, according to a study published in March, the mean, so the mean that tells us the parameter we're looking at is mu. So remember, the null is always a statement of equality, all right? And we said this was because the keyword was increased, is that no way the mean has gone up, all right? So we start with, hey, there was no change. Okay, it's still the same as it was in 2006. And what we're looking to show evidence of is the researchers saying, no way, no way. People spend more time talking on the phone. It's gone up. Now let's do the last one. So now we're talking about the standard deviation. So my parameter here is sigma, and the keyword is that it's decreased. Okay, so it's going to be sigma is equal to something, and the alternative is because it's decreased, there's no way sigma is less than something. Well, we knew what it was with the old manufacturing process, so we'll start with the null hypothesis that there is no change. And then the alternative is to look and say, wait a second, no way, it's definitely gone down. It's definitely decreased. All right, so notice in all these examples, the two values in the null and alternative are the same, okay? And the null is always a statement of equality, okay? And then we're going to look to say, no way, the value is decreased, or the value is increased, or the value is changed. Okay, now let's talk about type 1 and type 2 errors. Okay, so this is sometimes when you make an incorrect conclusion in hypothesis testing. Okay, so there are 4 outcomes. And let me go back and say what you can do with hypothesis testing. You can do what's called, you can reject the null. And what that means when you reject the null is that evidence supports the alternative. That's like saying the defendant is guilty. Or what you can do is you can fail to reject the null. And what that's saying is evidence does not support alternative statement. Okay. Notice how we don't say accept the null. You know, like if you think about the criminal justice system, they never say innocent. They just say the defendant was found not guilty. There wasn't enough evidence to show their guilt. Okay, so let me go through the two correct conclusions. You reject the null hypothesis when the alternative is true. Okay, that's like saying we found the defendant guilty when they are guilty. This decision would be correct. You do not reject the null hypothesis when the null hypothesis is true. Okay, so that's saying the defendant was not guilty when they are not guilty. So this would be a correct decision. Okay, but if you think about the criminal justice system, right? Like sometimes guilty people are found innocent, and sometimes uh, people who are innocent are found guilty. So sometimes the criminal justice system makes the incorrect conclusion. Okay, so when you reject the null hypothesis when the null hypothesis is true, so that's saying an innocent person is guilty. That's bad. This decision would be incorrect, and this is what's called a type 1 error. The next is you do not reject the null when the alternative is true. So that what that means is the person's guilty, but we find them not guilty. Okay, this decision would be incorrect, and this is called a type 2 error. All right, the one that we're most interested in is a type 1 error. So the probability of making a type 1 error we define as alpha. You actually, as a researcher, get to choose this. Okay, so you set this. Okay, this is going to be what's called the level of significance. And it's really important. There's going to be three common ones that will be used. It'll generally be 10%, 5%, or 1%, with 5% the most common. Okay. And every single problem in hypothesis testing that's given, I'll always either say test at the alpha is equal to 0.05, or I'll say something like the level of significance is 0.05. Okay, that's going to be one of the most important things that you're going to look for in hypothesis testing in the word problems that I give you, or the problems that I give you. When we actually get to those methods for solving either the critical value or the p-value approach, you need the level of significance to be able to conduct the test. And you'll see how that comes into play when we actually start doing some examples in the follow-up lectures. All right, let's end now talking about the conclusions, what you can say for hypothesis testing. Okay, so as I said, we never accept the null hypothesis because without having access to the entire population, we don't know the exact value of the parameter stated null. Rather, we say we do not reject the null, so fail to reject the null. Okay, this is just like the court system. We never declare someone innocent, but rather we say the defendant is not guilty. So either you can reject the null, or you can fail to reject them. Those are the two statements you can make, two conclusions. Okay, so let's do this. So according to a study published in March 2006, the mean length of a phone call on a cellular network was 3.25 minutes. So a researcher believes that the mean length of the phone call has increased. Okay, so this is what our test looks like. It was that the mean was equal to 3.25 minutes. And what we're saying is, wait a second, no, it's the researcher believes it's gone up. All right, so I'm not going to walk through the process here, but let's just talk about the two conclusions you can make, all right, and what they mean. Okay, so the first one says, suppose the sample evidence indicates the null hypothesis should be rejected. State the wording of the conclusion, and then finally, let's do suppose the sample evidence indicates that the null hypothesis should be rejected. Okay, here state the wording of the conclusion. So let's do A first. Okay, so suppose the sample evidence indicates that the null hypothesis should be rejected. So this is what's going on here. The statement in the alternative hypothesis is that the mean call length is greater than 3.25 minutes. Since the null hypothesis is rejected, there is sufficient evidence. So the evidence shows, okay, to conclude that the mean length of a phone call is greater than 3.25. So when we reject a null, what we're doing is we're saying we believe this is true. We're not saying what the new value is. We're just saying, hey, it's greater than it was. It's greater than 3.25. Okay, never say what the new value is, just that it's greater than 3.25. Now, suppose the sample evidence indicates that the null hypothesis should be rejected. Or should not be rejected. Okay, so we'll go like this. Since the null hypothesis is not rejected. There is insufficient evidence, okay, to conclude that the mean length of a phone call on a cell phone is greater than 3.25. So in other words, the sample evidence is consistent with the mean call length equaling 3.25. So there's no evidence to say that it's changed over time. Okay, so what we'll do, I know it's a lot in this first lecture here with the language of hypothesis testing, but I promise you as we go through and do, you watch the follow-up lectures that just walk you through a ton of examples. Um, this will definitely make more sense, and you'll get used to the word.